So remember, the amplitude is the absolute value of A, and in this case our A is 2, so our amplitude is 2. Alright, so we're going to start by putting down our x's and our cosine of x's. So we have 0, pi over 4, pi over 2, 3 pi over 4, pi, 5 pi over 4, 3 pi over 2, and 7 pi over 4. And then our matching cosine at those angles. 1, 1 over square root of 2, 0, negative 1 over square root of 2, negative 1, negative 1 over square root of 2, 0, and 1 over square root of 2. Now we're going to take this second cosine column and we're going to multiply it by 2 to get our third column. So we're going to get 2, 2 over square root of 2, 0, negative 2 over square root of 2, negative 2, negative 2 over square root of 2, 0, and 2 over square root of 2. So then when we graph these points, we're going to graph our x and our final column. So 0, 2. So when we graph these points, we are going to notice that we have our usual cosine graph, but so we graph these points. We're going to notice that we get our usual cosine graph, but it's been vertically stretched by 2. And notice that the maximum value is 2 and the minimum value is negative 2. So let's have you try this one. 1/2 sine of x. So here our amplitude is the absolute value of 1/2, which is 1/2. So we copy down our x's. 0, pi over 4, pi over 2, 3 pi over 4, pi, 5 pi over 4, 3 pi over 2, and 7 pi over 4. We copy down our sine of x's, which is our y. 0, 1 over square root of 2, 1, 1 over square root of 2, 0, negative 1 over square root of 2, 1, and negative 1 over square root of 2. Now we multiply this second column by 1/2, so 0, 1 over 2 square root of 2, 1/2, 1 over 2 square root of 2, 0, negative 1 over 2 square root of 2, 1/2, and negative 1 over 2 square root of 2. Alright, so now when we graph these points for sine, we're going to get something that looks like this, where our maximum is 1/2 and our minimum is negative 1/2. So we have shrunk this vertically by 1/2. So now let's combine what we know. So we're given the graph of our function to the right, and we want to find the amplitude, period, and phase shift. So first of all, our amplitude, we're going from negative 2 to 2. So that means that our amplitude is 2. Our period is when we start to repeat our values. So we have one period from here to here, going from negative pi to pi. So that's pi plus pi, so our period is 2 pi. So that means that k equals 1. This means that a equals 2. And then we have our phase shift. So first we need to decide, is this cosine or sine? So it looks like this is maybe cosine that's been shifted left by pi over 4. So x plus pi over 4. And our phase shift. So we have cosine of x plus pi over 2. We had an amplitude of 2 and our period was 1. So this is our equation. for our function. So go ahead and try this one, and then when you're done, come back and check your answer. So our amplitude here, well, we're going from -1 to 1, so our amplitude is just 1. It looks as though we have been shifted in which direction? Well, if this was sine of x, we have been shifted left. It looks like pi over 4. So that means we get sine of x plus pi over 4. And then we still have our, looking at our change in period. So going from -2 pi to 2 pi is 1 period. So that is, our period is 4 pi, but we're not done. That's not k, because remember that our period is 2 pi over k. So if we need this to be 4 pi, that means that we have 2 pi over 4 pi equals k. So that is 1/2 equals k. So we have sine of 1/2 x plus pi over 4, and that is our equation.